So let's take a look at this problem right here, finding this limit as h goes to 0 for this expression. Always try and directly plug in h is 0. You see automatically a problem since the denominator is 0, but also the numerator, if I plug in h equals 0, we get 0 up top. And so this is of the form 0 over 0, which is indeterminate. Remember, that doesn't mean the limit does not exist. It means that we have some work to do. And so now we algebraically proceed with this. So what we have is, to simplify this expression, we're going to basically clear out these the smaller fractions here inside the bigger fraction. So it's a compound fraction. Two ways you can do that. You can find a common denominator up top and subtract these two. And then once you've done that, combined it as one fraction, you can divide by h, which is the same as multiplying by 1 over h. I'm going to use a shortcut that I've showed you before. The least common denominator of all the smaller fractions, of course, h is, I guess, is h over 1, so its denominator is 1. But here we got h plus 6 times h plus 6, right? H plus 6 squared, and here we get 36. So the least common denominator of these two denominators, or the least common multiple of these two denominators, is 36 times h plus 6 squared. They have no common factors, so we just multiply them together. And so what I'm going to do to clear out these smaller fractions, I'm going to multiply the big fraction by 1 in the form of 36 h plus 6 squared over 36 h plus 6 squared, which of course is equal to 1. So I'm just multiplying by 1. But the magic is when I multiply across the top here, remember there's parentheses here, I distribute this through, multiplying it by 1 divided by h plus 6 squared, and then minus 1 divided by 36 divided by this stuff. When I multiply it by the h plus 1 over h plus 6 squared, the h plus 6 squareds will cancel out. And so up top, what are we going to be left with? Just 36, right? The h plus 6 squared will cancel with this one, and you're just left with 36. Here, the 36 will cancel, and you're left with h plus 6 squared. Of course, in parentheses there, that's what the top looks like. So I've cleared out the fractions. Now the bottom, I've got h times 36 times h plus 6 squared. I'm going to write that just like that. I'm going to bring the 36 in front, 36h times h plus 6 squared. Now, do not multiply this out. Do not multiply this out. Don't square the h plus 6 and then distribute this out. Don't do that. You want it factored. What we want to do is simplify up top. So we do want to square the h plus 6 here, distribute the -1, combine like terms, and then refactor. So we're looking for the common factor. And the problem, of course, is the factor h, right? When I plug in h equals 0, I'm going to get 0. So we're looking for a factor of h up top. And we're going to get that because we know the form is 0 over 0. So when you square h plus 6, of course, remember what that is. That's h plus 6 times h plus 6. You either FOIL that out or you use the special product formula of a plus b quantity squared, and you should get h squared plus 12h plus 36, right? Now that's in the parentheses, it's minus all this stuff, so you have to distribute that negative sign through. I'm just going to rewrite the denominator, no change down there. So I've squared h plus 6. Now I subtract that, so I'm going to distribute this negative sign through. And now we see how we can simplify. 36 minus 36 is 0. So those are going to cancel. I'm just left with -h minus -h squared minus 12h up top, -h squared minus 12h up top. And now, can we factor the numerator? Yes, there is a common factor of h there. Now, if I factor out, I'm going to factor out, since it's a negative here, I'm going to factor out -h. That's going to leave me an h. Since I factored out a -h from -12h, that leaves me a +12, right? -h times positive 12 gives me the negative 12h. And there's my h factor that I needed. So now I'm able to cancel that common factor there. So we'll divide numerator and denominator by h. And now I can plug in h equals 0 to what's left, right? I'm going to get negative the quantity h plus 12 over 36 times the quantity h plus 6 squared. I'm going to replace h with 0 in each of these cases. So I'm going to have 0 plus 12 in the parentheses there. Down below, I'm going to get 36 times 0 plus 6 quantity squared. So 0 plus 12 is, of course, 12. I get negative 12 up top. Here I get 0 plus 6. 6 squared is 36. So this is 36 squared. 36 squared is a big number. It's 1,296. Okay. Yeah, that is indeed divisible by 12. So if I divide both the numerator and denominator by 12, 1296 divided by 12 is 108. And so we get negative 1 divided by 108. And you do want to give me the exact value. So if you're numerically checking this limit out, that's a good idea, but you want to give the exact value of the limit. Okay. Now, very important again, just to rehash, make sure that you are clear in your work. You should show each of these steps and notice each time, what do I have in front here? What is that thing right there? What is that? It looks like this limit sign, right? Limit as h goes to 0 is there every time in the front. If you don't have it, that is incorrect limit notation. You will, you don't want to do that. That's incorrect. Notice it's gone here. Why? Because I've evaluated the limit by doing direct substitution. This function here, after we cancel, divide numerator and denominator by h, this function's continuous at 0. So we can evaluate it by direct substitution. And that's how we get the value. So keep your limit signs until you plug in and then give the exact value. Okay, hope this helps on this one.